Chinese automotive industry is showing the world that there is an alternate path. There's a different way to do things. They're very hardworking and increasingly innovative.
I saw these changes and how fast things evolve. The product development cycle has been shrunken down to less than 20 months. The 996 is real. The hardworking is real. The speed at which things move is real.
How is it possible? I'm like, I don't know if I have all the answers, but it's happening. You're 100% correct. It is real.
Intel Automotive is committed to accelerating the automotive industry's successful transformation towards a software-defined, sustainable, all-electric future at scale. Offering a best-in-class scalable product portfolio supported by regionally resilient manufacturing, all underpinned by decades of industry transformation experience. Hi, everybody. My name is Junko Yoshida. I'm the editor-in-chief of the Ojo-Yoshida Report. And this is a chat among three people that have a similar interest, namely automotive and China. And we have great guests. Let me first introduce Jack Weast. Hi, Jack.
Hey, Junko.
Jack is the Intel Fellow, and he is also the Vice President and General Manager of Intel Auto. And another guest we have, hi, Tu.
Hey, Junko. Thanks for having me.
Yeah, no problem. Tu Lee is the founder at Sino Auto Insights. And the reason I actually wanted to get these two guys together was, I think for most of us who don't live or who have never lived in China, China is a still opaque country. And yet we do see a lot of momentum, more than we had ever expected. And it's still a mysterious country. Tu has the great resume. He's got Detroit under his belt. I think you worked for Apple for a while, right?
I did in Silicon Valley.
Yeah, you were in Silicon Valley. And you lived in Beijing, how many years? 13 years?
About 12. I lived in Shanghai for almost a year. I was working at Ford, so.
Okay, so those three things are kind of golden. Meanwhile, here's Jack. Jack is not an ordinary sales guy. He's actually the Intel Fellow. And I was very struck by the fact that when Intel decided to restart its automotive business, Jack became the head, and Intel had the guts to move Jack to China. And he is overseeing the global Intel automotive business from China. So, I'm going to ask the first question. Jack, whose idea was that to move to China?
It's a great question. Well, when we were looking at really reinvigorating our automotive strategy, it was clear, to me, because I had come to China after COVID and seen what was happening and the level of innovation in the vehicles here, the number of new brands, the excitement in the market. It seemed like, we were seeing the future of the global automotive industry being created, here in China. And so if my responsibility is to lead the global automotive business for Intel, this is the place to be, because I think we're going to see more innovation and trends, start here and spread across the world as this industry continues to grow. So it was mutual, certainly, but the role of China in the global market was very clear to me from the beginning, and why it was super exciting to get the opportunity to come live here for a bit.
Yeah, I think it surprised a lot of people. But meanwhile, Tu, on the other hand, he lived in China when China wasn't that hot yet, right? But Tu actually saw the future then. And I think Tu is now future for the Western automotive industry now, because there's a gap in terms of understanding what's going on in China. But also, there's a gap that there's reality a lot of incumbent OEMs are facing. So I'm going to give microphone to two. That what have you learned when you were in China? 12 years in Beijing, 1 year in Shanghai. What have you learned then, and how does that apply to now?
The first thing that I learned about China from a life standpoint, business standpoint, is that things move really fast. And this is coming from the guy that lived in Silicon Valley for 7 years. So, progress was made in my little corner. It seems that Jack and I would have been neighbors because I lived in CBD, and so just that corner, Guanghua Lu, right at that corner, there was no lights, Jack. And when I got there in 2009, there were little carts driving around, people riding bicycles, people riding electric little scooters, and traffic. That would be a parking lot right at that corner between like 4 and 7 p.m. Now it's clear. And then you would have this cloud of, let's say, we won't say pollution. Let's just say some overcast skies almost daily. But yeah, and so, but that all cleared up within the 6 or 7 years, first 6 or 7 years. And generally speaking, I'm told now that most days are pretty good on the pollution side, and you start to see small autonomous delivery vehicles on these roads now in CBD. So they're starting to leak out from Yizhuang into the mainstream areas of Beijing. And I think Beijing is a bit of a microcosm, at least on the tier 1 and tier 2 cities. Tier 3, tier 4, they're going to take a little more time, a little more investment from a transition over to new energy vehicles. So
You started living there 2009 or before that?
2009, I visited for the first time for the Olympics. My girlfriend, who's now my wife, had transferred over for work. And so I visited her in 2008, and I pulled the ripcord in 2009. And we left August 16th of 2022.
Wow. 2022.
Yeah, very cool.
I would argue that the time frame that I saw was really where the tech companies started to establish themselves as global players. The original Baidu, Ali, and Tencent, and now the second and third wave. Because we're getting to a third wave now, because the second wave is Meituan, Didi, and those companies, and now we're looking at Temu, Shine, and those companies now, kind of a third wave.
Wow. So that comes in phases. But, Jack, when before you moved to Beijing, you obviously have lived, I mean, have visited China for a number of times. Is that right?
Yeah, I've been here dozens of times. I think the first time I was here was early 2000s sometime, and I remember, I remember being in Shanghai, in the Huangpu River there, and all the boats in the river were coal powered. And there were some cars on the road, but the majority of the roads were filled with folks on bicycles or, kind of three-wheel moped type things. And it's just unbelievable to see the progress, in the country, since then. So yeah, I had a sense of it for sure and traveled here a lot for work, but I'll say living here gives me a totally different appreciation of that China speed that Tu was talking about. Even just in your daily life, services like Meituan, which for our U.S. listeners, the closest parallel you could make is it's sort of like a Uber Eats type thing, but you can get anything, not just like food from restaurants. You can get food from grocery stores. You can get household goods. You can get almost anything you want delivered to your door, often in 20 minutes. And so the speed at which you can get anything your heart desires and never leave your apartment if you don't want to is just incredible and unheard of. And so that China speed aspect is daily life as well. Payment systems fully digital everywhere, and it's not that kind of NFC thing where you got to like try to tap your phone and half the time it works and half the time it does.
Download 10 different apps.
Yeah, and well, a wrong app, or like, okay, this is taking too long. Let me just take my card out or whatever. No, everything here uses a digital payment app. It's one app. It's a QR code. Whether you're buying, food from a street vendor, or you're taking the bus or the subway, groceries, anything, everybody uses it. And it is so fast and convenient. You don't even need to carry a wallet. You don't carry cash or credit cards or anything. So the pace of life here is incredible. We hear about the 996, sort of working style, 9 a.m., 9 p.m., 6 days a week. People here work very hard. They're very hardworking and increasingly innovative, as we were talking about earlier. So I didn't have a full sense of that, I think, until I actually moved here, and started living here on a daily basis. And you feel this energy. You probably know a bit of Chinese, but I think there's this word called shui in Chinese, which is kind of the loose translation is just this intense, frenetic kind of one-upsmanship where you're always trying to like get ahead of your competitors, and that mindset sort of embodies, I think, how companies here think, and why this drive to innovate and outdo each other is so strong, and what makes it such a dynamic, incredible environment to be in.
Jack, it's happening right now in the automotive space in China, right?
Yes.
The intense competition, and the product development cycle has been shrunken down to less than 20 months, generally speaking, because the platform, the battery platform, the pack, is pretty much the same. You can extend it, reduce the length, but generally speaking, the top hat is nothing because it's mostly software.
Yep, you're totally correct. In fact, we I'll just give you two contrasts. Two different customers. I won't name the names, obviously, but one here in China. 2 weeks ago, we were awarded a design win that'll ship next year. So less than 12 months, a new vehicle will ship with a platform inside. Then I was in Japan last week, and we were talking to customers about a vehicle opportunity in 2029. So 4 years later, evaluating the same solution.
If I may, you are newish as a resident of Beijing in China, so it's real. When I started writing the newsletter, and Junko and I have known each other for a while now, because I saw these changes and how fast things evolved. I won't say change, let's say evolve. And the 996 is real. The hard working is real. The speed at which things move is real. It's not exaggerated, right, Jack? Because I think a lot of Westerners are like, how can that be? Because I only work 35 hours and I'm so productive in Europe when I work 35 hours. And it's like, this is impossible.
Yeah, I get that question all the time. How are they doing it? How is it possible? I'm like, I don't know if I have all the answers, but it's happening. You're 100% correct. It is real. It is not hyperbole. This is happening. It is happening this fast. And I think the Chinese automotive industry is showing the world that there is an alternate path. There's a different way to do things. We don't need to always be so burdened with that's the way we've always done it. This industry has such a rich history and legacy, which is incredible. The modern passenger vehicle is still one of the most amazing things from a supply chain standpoint, that all these things come together and pump out vehicles at the volume that global automakers do. But something's changing, though, in the industry in terms of how long it takes to build a vehicle. Traditional norms, I think, are being challenged. Companies are asking, why do we have to do it that way? Okay, I get that's the way it's always been done, but why? What's the reason for it? Do we still need to do that today? And that's like sort of questioning, that legacy, which is something to respect, certainly. But I think there's a healthy skepticism as well on where do we need to deviate from that to innovate.
And I think one thing to add to Jack's point is that there's a need for innovation in Asian countries and Asian cities. Generally speaking, Europe, I think there are 30 or 40 European cities with over 1 million people, there's probably 2 million people in Jack's neighborhood.
Yep.
So, so it's not they're just creating these new toys. It's a need. There's still a ton of traffic in China and in Beijing, and so the demographic for consumers is much different than in Europe and the United States, where a BMW owner might be 20 years older in Europe or the United States as opposed to China. And so different customer segments, different needs, different wants and desires. And so the fact that China is innovating is Jack being able to look around corners and see around corners and say, okay, when will this project out in Japan? It sounds like 2029 when China's looking at this next year. So it's just one of those things where you almost speak a different language when you're calling back to Santa Clara, I think, Jack. But you can talk to me. You can talk more about that. So
I think I come from Japan, so I'm from the era of a 2029 person. But I do see when Japanese saw Silicon Valley, I think they saw that. I think that was a shock to them in 1990s, right?
Mhm.
Now it's happening in China, but in a much different scale. Sort of like we're watching the history in fast forward, and it's really ultra fast forward mode that we're watching what's going on. So I want to focus on the what's happening in the automotive market in China. I think Chu's point is it's great because the demand, the desire and wants of the consumers in China very different from those in the West. That said, what are the things that motivating them? What are the features, or is that a software defined vehicle? Is that the autonomous features, or what are they looking for?
Well, I think it actually goes back to something that you mentioned in terms of consumer expectations changing. So I think that we think about who's buying cars today. It's millennial and Gen Z folks, and these are people who grew up with an iPad in their face and an iPhone in their pocket, and so their expectations for a consumer device.
or Xiaomi,
Sorry, Xiaomi, excuse me, here in
Huawei, Xiaomi, those things.
So their expectations are that a consumer device has the latest and greatest technology always. And so whether you're buying a phone or you're buying a car, the consumer expectation, it has leading node silicon, not 5-year-old silicon in it. That the software has a major update cycle, kind of every 6 months. And so to meet that consumer demand, that's how you go from design win to deployment in 12 months. In the example that I gave earlier. And then it becomes, I think, a little bit of a necessity, but also enabled by how they're thinking differently about the vehicle. So if you're going to clean sheet design a vehicle, you would never design a vehicle with 100 ECUs in it and a mile of copper cabling. But that's that legacy, from decades and decades of that architecture being built one ECU at a time, that's what most, modern vehicles are like.
And that's up and down the supply chain. Sorry to interrupt, Jack, but that's up and down the supply chain, not just at the OEM level.
Yeah, you're absolutely correct. Yeah, and so it's so entrenched into how the whole industry operates and the supply chain side of it as well, that when you take fresh eyes and you take a blank sheet of paper and say, you know what, my value is the top hat. I'm not going to innovate and differentiate on how amazing the sound of the engine is at Autobahn speeds because I drive no more than 20 kilometers an hour because I'm driving across Beijing. So what even matters to a car is much more about the tech and the IT experience, which is to say, let's figure out a platform that's as simple and optimized as possible, where a lot of that complexity gets designed out so that you can get to market then as fast as possible with something new. And so I think it's a combination of market expectations and then how to meet those by starting with clean sheet design and saying we don't have to build cars the way we always did, because my what's important to me about this vehicle is different now. The KPIs or key performance indicators that's going to make this car valuable is not how it performs at high speeds or corners as you're driving around, the French Riviera or something. It's how comfortable and what is it doing to entertain me or keep me productive as I'm going from one side of a mega city to another. And these are, to Tu's point, all across Asia and Southeast Asia in particular. So what matters in a car and what matters about the driving experience comes from a completely different starting point than the traditional Western auto industry. So I think that's something that's not appreciated as always by car designers in the West.
If that is the case, that how does that translate to your global customers that who may not have the same starting point, and what can they learn from that?
Yeah, I think the first thing we try to get them to learn is, what are you waiting for? why, why are you waiting until 2029, to adopt a great new platform from Intel when your competitors in China are going to be shipping it next year and increasingly exporting those vehicles to global markets? And so now it's not just contained to China. These cars are showing up all over the world. And that's going to certainly present some competitive challenges and pressure for traditional automakers that aren't embracing these new approaches, because their products side by side simply just are not going to be competitive. If there's twice as much technology and it's a similar or lower cost, consumers are going to vote with the experience they like better. And who are those consumers? Younger consumers that care about tech. What kind of app store does it have? What kind of rear seat gaming experience does it have? What kind of AI applications does it have? A conversational voice assistant. All these things that young people are embracing and integrating into their daily lives. Those are the things they're asking for. They're not asking what kind of brakes does it have, or what kind of suspension does it have, or what's the motor sound like? These aren't priorities to a lot of these buyers. And so we try to get them to understand is this new reference point is spreading. And I think eventually younger generations around the world will resonate, with vehicles that offer those kinds of things. And that's why we say in many respects, these cars represent the future. And a reference point for the rest of the global industry to embrace, and find a way to do themselves and innovate also, and create that innovation spiral globally now. I think that's healthy and good for the industry.
And Junko, if I may add a few different things, Jack had uh, I believe, kind of described moving from in the automotive space a product focus to a customer focus, because tech companies are very customer focused. Okay, they create stickiness, and they are able to create new features based on the data that they collect and some of the trends, and anticipate some of those trends. Now, when you're a traditional automotive OEM, you're looking at 5 year, 6 year product life cycles. You're trying to eke out millions of units in order to recoup the capital cost, the $1 billion, $500 million that you've invested. And so there's all these different things in the automotive space because they're not great at software. And from a sales standpoint, traditionally, they don't touch the customer. The dealer touches the customer. So they're a B2B um, business. And, a few of the other things, I'd also look at AI technology as helping not just the younger customers, but in Europe and the United States, where there's an older population. If my grandmother, who's 85 years old and can barely drive, if she can talk to the vehicle, open the window, have some ADAS or intelligent driving features that make her safer, that's good for everyone, right? That's going to bring down insurance costs for everyone. Where China is very different, at least at the four-wheeled passenger vehicle segment, is that as Europe and the United States, their average selling price for MSRP for a passenger vehicle has creeped up, and we're seeing inflation. In China, most vehicles are sold under $45,000. I think it's 90% of all passenger vehicles sold in China are under 300,000 RMB. So they live in that mass market, and that scares the crap out of the European Union. It scares the crap out of the United States government and the legacy OEMs, because for the foreseeable future, let's just say through 2030, they don't build a profitable car without Chinese batteries. That's full stop, full stop. And so with the tariffs, and now today they had announced the Biden administration is going to restrict or ban Chinese connected technology in passenger vehicles. Everyone's trying to scramble to figure out, they're looking at their internal risk management teams. What does this mean to us? Do we need to source? Do we need to find an alternate source for our bill of materials for which parts, blah, blah, blah. And so a million things going on. But at the end of the day, Jack is in, and I'm speaking for you, Jack. So if this is incorrect, you let me know. Jack is in China because it's a 25 million unit market. It's the largest market in the world. It's almost twice the size of the United States. And so that's where the innovation is happening. It's going to trickle into Europe. It's going to trickle into the United States, maybe for different use cases. But at the end of the day, Intel will supply the power in order to generate all these different features. What features is really up to the software partners and the OEMs. But I think that's the most exciting part for me as I watch how the industry evolves.
One of the things that I want to talk about, because Jack is working for a chip company, not the automotive company, I want to, this is the close to my dear to my heart. I think too. You actually wrote in a recent newsletter of yours. You talked about some of the leading Chinese OEM brands like XPeng, Neo, Li Auto, and those Chinese automakers are already announced they taping out their own automotive chips. I wonder how real are they, and what kind of things do these chips you wrote about actually do, and what are the equivalent to the Western chips?
They are investing a lot of capital in silicon design. Now, they're also partnering with companies like Black Sesame and Horizon Robotics, SMIC. But if you look at the geopolitics of the last few years when it comes to capital equipment, let's say ASML, things like that, they're also playing defense because there's a risk that things might get cut off tomorrow. With the NVIDIA server chips, that happened. I think it's the H100 chips, and NVIDIA launched a new chip, the A100 chip, within 6 months or something like that. And so, with Intel, it's just reacting quickly to the different geopolitics involved with Europe and the United States. And so, with that uncertainty, these companies not only are they looking at what Tesla's doing, because they're looking to dethrone Tesla specifically in China, but to a lesser extent in Europe. But they're also looking at their domestic competition. How do we differentiate ourselves?
Right. But these are mostly the ADAS chips, or these are mostly digital cockpit chips, or what are they talking about?
So obviously the holy grail is the machine learning AI chips, but they're looking at transitioning whole hog because and we're looking at companies like DJI converge into intelligent driving as well, because what do they have? They have a great hardware software system that uses LiDAR, that uses radar, that uses sonar to draw a picture of the land around their drone. And so companies like that are also looking at designing their own silicon. But it's just an interesting time, because if you, and Jack, you're there every day, if you kind of squint, a lot of these cars look the same. And so if you look at the features, if let's say NVIDIA is driving the AI stuff and then Qualcomm chips are part of the infotainment stuff, how do you differentiate yourself? You got to move into designing your own silicon or using an Intel Automotive chip that offers a different set of features or specific benefits.
Let's talk to Jack, because what Jack is saying, and as a peer to peer or as a potential competitors, you see these companies, your customers, but also your customers are certainly interested in developing their chips, right?
Yeah, and we see the primary motivating factor for that is a desire to innovate and differentiate. It is very difficult to deliver new and different kinds of experiences within a car if everybody's using the same silicon and the same software. And so that's often where it starts. Companies certainly do look at Tesla and they're envious of, oh, I wish I had my own kind of FSD chip or something like that. But the interesting thing that's happening, and we have this conversation a lot with customers, is there's a lot of desire to do it, and some are doing it, and you mentioned some of those companies. But the cost to develop a high performance leading node chip is just growing exponentially. It's hundreds of millions of dollars, to do your own custom high performance SoC. And most automakers just simply can't afford that. The economics of it don't work. That's why we've offered a different approach, which is really more to give them a hybrid custom option, where with an open chiplet, based architecture, an automaker or ecosystem provider can put their unique IP on a chiplet. And with Intel's Foundry capability, we can integrate that chiplet into one of our roadmap products. So that way, they're not reinventing the wheel. They're focusing their limited silicon design resources on just the part that makes sense, that actually differentiates them in some way. And so we think, at Intel, that that's a better path going forward, because it's just really not feasible for every automaker to build their own SoC and then all the huge software investment behind that. But many do have unique IP that might make sense, in silicon. And so we see it as our job to provide an open platform and an open architecture that makes it easy for them to do that in a cost-effective manner.
That's a very different story of, chiplets as we know in the West are the ones that chiplets that Intel made or AMD made, something really humongous out of science project type of big chips, right? But what you're talking about is a lot more down to earth, sort of like a new version of SoC in a way that you actually integrate the car company's IP in the form of chiplet, and you will package together what you've got with their IP and create the solution. That's what you're talking about.
Yeah, exactly. And the need for chiplets at the beginning is because of the challenges with monolithic dies, as you were just describing. And there's a real scalability problem with those, because if you build a huge monolithic die that meets the high-end vehicle requirements, you just can't scale that down from a cost standpoint. And that's where automakers get frustrated that, oh, I got to use a different solution at the high end than I have at the low end because I don't have something that's scalable. With the chiplet approach, you take a monolithic design, you disaggregate it into its different parts. So, for example, the CPU and GPU could be different chiplets, and that allows you to scale independently those chiplets from each other. And because a chiplet is smaller than a monolithic die, you get higher yields, which helps reduce cost. And so it's more flexible overall. And then with standards like UCIe, which is an industry standard, die-to-die interconnect for chiplets, and modern foundries like Intel foundries, you can build a chiplet anywhere. You could build it at Intel, you could build it at TSMC, you could build it at Samsung, and we could integrate that in, and allow a customer to have their own IP inside a single socket, kind of SoC that's made up of disaggregated chiplets.
I just had a flashback because in a prior life, Jack, I was part of the commodities team for graphics for Apple during the transition to Intel Silicon. And so, oh man, the integrated, chips for some of the lesser least expensive Mac products, and then Nvidia and ATI were two of my GPU suppliers basically, and then my boss worked with Intel, but it was a crazy time. That was like back in 2004, 2005. So, man, just flashbacks from that. But anyways, I digress. Go ahead, Junko.
No, but yeah, that's a good setup because what I was thinking is that the way Jack explained chiplets makes a lot of sense to me. That was originally, I got so excited about chiplets. But as time goes by and I interviewed a lot of people, I realized, man, I thought that was a dream. But it looks like everybody's still struggling that it chiplet ecosystem seems to be already here, and yet it's not here. A lot of people are still talking about, like IMEC, right? IMEC is I think Bosch was the team leader and trying to put together automotive focused chiplet standardization, but it's not there yet. I mean, how do you see that? I love the concept. I really wish that we could do this, but what are the steps that we still need to take?
Actually, Jack, can I ask a qualifying question before you answer that specific question? Because what's really important, Junko, is that it's not just Chinese EV companies that are looking to design their own silicon. The big legacies are also looking at doing it too. And unfortunately, there's a culture clash, there is a speed clash, there's an understanding clash. And it's not only on the hardware side, but on the software side, because, Intel can fab amazing silicon, but if the software doesn't work with it, then we're going to have a lot of bugs. And so, like, how much teaching do you have to do, Jack, when you're talking to a lot of these automakers, these tier ones that want to wring out every ounce of power from your silicon? And like, because in me talking with the OEMs here, they want go from 0 to 100 miles. Oh, we can design with the best of them. I'm like, what? I mean, I use my poker face, but I'm like, really? Okay. We're talking like NVIDIA and Intel. They think they can design silicon like you guys. And I'm like, okay. Anyways, but please, I'm sorry.
No, yeah, it's a fair point. I mean, one of the first things we do when customers are interested in this, maybe they want to build their own silicon, and so they're talking to our foundry team. But then maybe they come later to us at Intel Automotive and say, okay, we're thinking about a chiplet approach, and it's important to workshop it because not everything makes sense to put in a chiplet. And if the size of your IP is so small, and it doesn't, the economics to do a chiplet doesn't make sense either. And to your point, Junko, in terms of a chiplet ecosystem, I think, and this is where maybe kind of the hype curve has got ahead of itself in the sense that this future world, which I think will exist someday, where chiplets are literally like Lego blocks and they're interoperable from every manufacturer, and you can just snap them together and boom, you've got a working SoC. I think when people think about chiplets, they think that's what it is. And maybe that future is possible someday, but that's not how it works today. Because even if you have a chiplet, you have a physical interconnect. Okay, what's the protocol on top? What's the fabric, that communicates between different elements of the chip? What are the latency or memory requirements, for the custom chiplet that I'm adding in? And can the rest of the SoC, handle that based on what else is running? So it's really the best way to think about chiplets is you're disaggregating a monolithic architecture for benefits of better yield, better scalability, better flexibility. But those partition points where you kind of divide up that monolithic die into those chiplets are going to be different for, an Intel-based product compared to someone else's, because it's just the nature of silicon design, at this point. So perhaps someday we'll get there, but it's definitely technically possible, for customers to bring their own chiplet, integrate it in, and for us to deliver back to them. Intel made a public announcement recently about AWS, and Xeon, doing kind of a custom Xeon. So we really do think that is the future. It's going to start, baby steps, and then eventually maybe we get to a big, huge, Lego block style ecosystem. But that's going to take quite a long time to come to full realization.
So really, the first step is that to figure out how to put things together within Intel's own ecosystem with your customers' sizable IP. Is that it's already possible?
Yeah, definitely already possible, and they can build the chiplet with UCIe, so it's still a standard interface. So they could take that chiplet to somewhere else, but the design of that IP is going to have certain assumptions on what's the protocol on top of UCIe. Is it UCIe? Is it something different? Is it CXL? Is it? And then what are my memory requirements? What other IOs and things do I think are across my chiplet boundary into something else? And this is where you have to still think about it as a system that you're designing. But it's definitely technically possible, and we will be doing that with customers. But that's a slightly different, vision than like you say, that there's thousands of chiplets on the open market, and you can snap them together like your Fisher Price Legos.
Lego.
My first chiplet SoC or something.
No, but it's interesting because, as you said, I think hype did get ahead of of the reality, in a sense that, oh well, it's not going to be Lego, man. What's the point of doing chiplets? But you're saying there's a practical way to practice chiplets, and there's a way to solve this problem even within a limited ecosystem. That's what you're saying, and then probably that's a I was going to ask you that what would be the if you talk to OEMs or tier ones in China, what's your opening? Is chiplet is your opening?
To us, it's a capability in our portfolio, and as Tu said, it's really global. It's both China OEMs as well as global OEMs, and every OEM is different. Some have very strong internal R&D capabilities. Some might have acquired an AI company, and now they want that AI company's IP to be inside their their cockpit chip. Some just generally rely on the ecosystem and their tier one partners. So not going to be interested. But maybe the tier one has unique IP. Maybe they have sensor IP or something like that, or particular camera vision IP, and they'd really like that to be featured, inside of a cabin chip of some kind. So we see interest both not just with OEMs but also tier ones as well, because everyone's feeling squeezed. Everyone feels competitive pressure, and everyone wants an opportunity to differentiate. And this is a way for them to differentiate in silicon, whereas before their only opportunity might have been to do that in hardware. And if you don't have the silicon features that you need to differentiate, there's really only so much you can do with software, which is why the experiences feel so uniform today, and you don't feel terribly different, from car to car. And that's what automakers are hungry to move past.
I think you opened my eyes here, because what the world, that the way we cover the automotive industry for the last 10 years, we talk about which chip companies has an edge over the other chip companies, and it's like we do the list of automotive chip companies and who is winning. But what you're saying is that if true, that is like what we're going to see, the disaggregation of the chips, and it's not just one company owns everything. It's like Intel, can you help me to put my special sauce into my chip? I call it my chip, but actually I need Intel's help. That is where you guys come in, right?
You get essentially what is a custom chip, a custom SoC built only for you, but 3/4 of it we already built. It's got the GPU, it's got the CPU, it's got some AI, some IOs, some media, all that. But then we bring that last missing piece, that unique piece from the tier one or the OEM in. Our foundry packages all that together and delivers it only to that customer. So you kind of get the best of both worlds. You get all the benefits of a fully custom design, but at a fraction of the cost. And that's why we think it makes so much sense.
In Junko, I think we should also always remember that there's a Didi, there's an Uber, there's an Amazon that are creeping around that want to get into transportation. Let's not even call it passenger vehicles. They want to get into transportation. Their specialty is logistics. Amazon, for instance, right? Uber, their specialty is logistics. And we've seen Uber with the partnership with Waymo now. And so in China, at least, the intelligent driving robotaxi startups and the native OEM China EV Inc., who's doing intelligent driving on their own, NIO, Li Auto, and Xpeng, they're starting to converge, because there's companies like Deep Route that are partnering with Great Wall in order to try to differentiate themselves or play catch up. And so that's not happening as quickly in Europe or the United States, where robotaxi companies are still very separate.
Yeah, separate, right.
Yeah, with the exception of GM, because they acquired Cruise. But these companies need to reconcile everything that's going on. And, China already has probably 1,000 robotaxis on the road. just south of where Jack is, in a district called Yizhuang. And I don't know if you've been there yet, Jack, but I can get you in a robotaxi if you want to try one or two out. But the convergence is going to be looked at in Europe and the United States from an OEM standpoint. And then the asset light companies, the tech companies that want to get further into, building out their users, like an Uber, they're going to become major players, and they're going to need Intel on the server side and on the intelligent driving side at certain point in time, in my opinion. So
Yeah, that's interesting because we are so used to think about automotive industry in a very structured way. Here's OEM, here's tier one, and here's the chip suppliers, and then we sort of cut. We make a table, and there's a top is the tier, OEMs, and we think in that box. What you're saying is that service companies who have nothing to do with the cars, and they're kind of all jumbled together in a way to create the new business and create differentiation. Is that what you're saying too?
here's a few different simple cases. Foxconn, who we know as a contract manufacturer to everybody, they build an electric vehicle in Taiwan under the brand name Foxtron. Magna Steyr, they're currently contract manufacturer. Bosch is also doing intelligent driving and certain things. Now, when they're suppliers, very low margin, and they get beat up all the time. And Jack, I don't know if you're more of a high value supplier to the automotive, so I would call you a partner. But if you ever become a supplier, they're going to beat the heck out of you too. So always add value, because if not, they're just going to not treat you very well. And so the Magna Steyrs and the Bosches, they ultimately want to move up market as well, because they want to provide the services. And if you think about it, they're probably a bit better equipped to compete in the 21st century transportation sector than the OEMs, because the OEMs have to lop off parts of their company, because they're still building and selling and designing and investing in ICE vehicles. Okay. And they can't make that transition as quickly as possible, especially now because Europe and the United States has kind of slowed their transition from to clean energy vehicles, which puts them in a precarious position. Some of them are going to be caught in no man's land. And companies like Volkswagen Group and Stellantis that have 10, 12 brands that they're managing, it's going to be like GM in the early 2000s when Oldsmobile went away, when Pontiac went away, when Hummer went away. And so that's what we're going to see, unfortunately, with Volkswagen Group and Stellantis. They're going to have to reconcile, how much their capital they're able to invest and which brands they want to keep around.
Wow. That is definitely eye opening. Okay, so in order to wrap this up, let me ask two of you. All these things what I just heard is China is different, and they're approaching automotive industry or market in a very different way. But what are the things that China needs? I mean, it's not like China has everything. China is trying to build everything, but it doesn't have all the components. Components meaning the building blocks. What do you think, too? I'm going to start with you, too. What do you think that China need in order to make the dream possible? The way you described it, maybe they've got all the elements already. I don't know. What do you see? What's missing in China?
So the biggest thing that I've seen since we moved away is kind of the economy is still not operating at 100%. And there are challenges, structural challenges that need to be addressed, because the price war has really brought an excitement into the new energy vehicle sector for China, but there's going to be a lot of collateral damage, let's say in early 25, mid 25, from the companies that aren't going to be able to operate efficiently. And then if you look at the geopolitics of Europe and the United States putting up pretty high tariffs. Europe, because they want them to build locally, in the United States, because they don't want the China EV companies to gut the Detroit 3 effectively. It makes for an interesting 25 through 2030, because at the end of the day, as a U.S. consumer, I want the best products that give me the most value. And currently, that's the Chinese EVs. And so with regards to what they're missing is a global opportunity, effectively, because the pressure to export is immense because of the price war. And there are a few winners. Tesla and BYD are the only profitable companies, full stop. And, they're really the only companies that are designing their own silicon, and designing their own battery technology. And so all the OEMs want to do that, but a lot are going to have to rely on Intel to be their partner in order to try to keep up with a Tesla and a BYD. And so this is where, Jack, you probably have potential client meetings and everybody says, we want to eventually bring this in-house. And you're like, yeah, of course. But between now and then, we're happy to partner with you, because the reality is they're not going to have the capital. They're not going to have the sales volume. And so they're going to have to buy for a very, very, very long time. And this creates a huge opportunity for companies like Intel that are refocusing efforts into the automotive space, specifically in China.
What do you say, Jack?
Yeah, no, at Intel, we say, we need to listen to our customers and help understand their challenges and problems. And if we can help them solve those, they'll value us, as a partner. And so I'll just share what we've heard over and over again from customers across China. And that is they want a solution that's more scalable. We talked about that already, something that scales, a common solution that's software compatible, maybe even pin compatible in the ECU, that scales from the top premium luxury vehicles all the way down to the low cost vehicles. They also want something that's more open. They want to choose the operating system, the hypervisor, the software elements that go on that platform. They don't want to be told, by the silicon supplier, what their limited choices, might be. They also want something that helps them innovate, and differentiate. And that's where, kind of our chiplet offering comes in. And most of all, and to mention this, the cost pressures are huge. So at Intel, we can't just be showing up and saying, hey, here's this cool piece of silicon, spend more on it. No, here's a solution from Intel that actually will save you money, that would reduce the overall cost of your vehicle platform, because it allows you to consolidate workloads, reduce the number of ECUs. It increases the efficiency of the energy management, in your e-motor. It allows you to, drop the voltage of the battery, have smaller capacitors, a cheaper, lighter thermal solution, because your energy flow is more efficient, so there's less loss and leakage and heat. And from a software standpoint, embrace open source application frameworks, not proprietary, software that adds cost, to every vehicle. And so that's what we hear over and over again. And what we're trying to do with our portfolio is not only provide leading technology, but, for what service? In the service of helping our customers be more successful. What does that mean? Helping them reduce cost and increase innovation, at the same time. And so that's what we're trying to do, focus on those dual goals. And if we can do that, I think we'll have lots of partners, as you say, too.
All right.
Jack's good at this.
Yeah. Well, we're going to have like 6 months from now, we're going to review this. Where are we now?
Jack's very good at this.
Yeah. All right. Well, thank you for coming to the show, and we'd like to continue this conversation, because there's a lot of things both of you gentlemen, taught me today. Thank you very much.
Anytime, Junko.
All right.
Always a pleasure, Junko.
Yeah.
Thanks.
See you soon. Intel Automotive is committed to accelerating the automotive industry's successful transformation towards a software-defined, sustainable, all-electric future at scale. Offering a best-in-class scalable product portfolio supported by regionally resilient manufacturing, all underpinned by decades of industry transformation experience.